Okay, so here we are continuing for indicatrix of different minerals like uniaxial and biaxial. So you can see here this is shape of the indicatrix of uniaxial and this is for biaxial. So starting with uniaxial, so what happens? Before going to different type of figures, different type of indicatrix, let's discuss what is indicatrix. What is indicatrix? It is a geometric figure. It is a geometric figure that is obtained by taking the refractive index, along the vibration direction, refractive index of different rays. For uniaxial we are considering refractive index of O ray and E ray. For biaxial we are considering refractive index of fastest, slowest and intermediate along its vibration direction. Okay, so vibration directions are 2 in case of uniaxial and 3 in case of biaxial. ठीक है? For considering refractive index is the magnitude or radius you can say, and in which direction we are going to plot that refractive index, that is parallel to the direction of vibration, that is along the direction of vibration of the, either you are using refractive index of ordinary ray in vibration direction of O ray and refractive index of extraordinary ray in vibration direction of extraordinary ray. Okay, so what are the different vibration directions for ordinary and extraordinary? For uniaxial I am telling, for ordinary the vibration is in basal section, that is in basal section. So what is basal section? Basal section means which section is perpendicular to C, that is perpendicular to C. Basal section doesn't mean that is perpendicular to optic axis. Most of us think that in uniaxial mineral the optic axis is perpendicular to the basal section. Yes, obviously it is perpendicular to the basal section, but that is a coincidence. That is not the logic. Okay, the section which is circular, if I will take perpendicular to that, then that will be my optic axis. Okay, if any section is, I am getting a circular section, I will define whether that will be circular or elliptical. So if I am getting a circular section in the indicatrix, if I will put a perpendicular to that circular section, that will be the optic axis. That doesn't mean if I will take a perpendicular to basal section, that will show a optic axis. Consider for basal biaxial mineral, if you are taking an perpendicular to basal section, you will never get the optic axis because there are 2 optic axes. Okay, I will define this logic what I am telling. In uniaxial, that is a coincidence that optic axis coincides with C axis. In uniaxial mineral what happens? Optic axis is parallel to C axis. So what is basal section? Perpendicular to C. So here basal section is circular. If I will ask that which section you will get circular, and I will put in option, one option is basal section, one option is principal section, one option is perpendicular to C, one option is perpendicular to optic axis. The answer must be perpendicular to optic axis. I am asking the question in which section I am going to observe an circular indicatrix. In which section I will obtain a circular indicatrix. The answer should not be basal section, the answer should not be principal section, it should not be perpendicular to C, it should be perpendicular to optic axis. I have given this question, now I will define that. Okay, see the indicatrix, then we will go for that. So what happens? I have told you that ordinary ray that vibrates in basal section. Okay, and extraordinary ray that vibrates in principal section, that vibrates in principal section. Okay, or you can say ordinary ray vibrates in AB plane. In AB plane, if there is a crystal, what are the uniaxial minerals? What are the systems those crystallizing in what are the minerals or what are the different systems they are giving uniaxial minerals? They are coming under uniaxial minerals. What? Tetragonal and hexagonal. And isometric? Same thing. That is isotropic. That is having which type of indicatrix? Oblate, roulette, spherical indicatrix. Talking about isotropic minerals or isometric system, that is isotropic because it is having same properties in every direction, so it is showing a spherical indicatrix. That means the refractive index is same in each direction. I need 3 pens. So you can see here what I have told. I have to put the refractive index in different directions. Okay, so let's say this is C axis, this is B, and this is A. A is front to back, B is right to left, C is up to down. Okay, so these are 3 axes. If I will take refractive index in each direction, okay, for isotropic mineral, what will happen? I will represent refractive index A here, that refractive index A here, that refractive index A here, because refractive index is same in all direction, in X, Y, Z, all direction A, B, C, in all 3 directions the refractive index will be same. So if I will take same refractive index in every direction, the resultant 3-dimensional structure or figure will be a sphere. Okay, that means each section is circular in case of isotropic mineral. Each indicatrix section is circular in case of isotropic mineral. Now talking about uniaxial for tetragonal and hexagonal, what will happen? Here it is the C axis, this is B and A, right? So if ore vibrate, if ore enters the mineral and it will tend to vibrate, it should vibrate perpendicular to the optic axis, or it should vibrate in the basal section when talking about uniaxial mineral. Okay, so you can see if this is C axis, I have taken this as C axis, this is A, this is B, and this is A. Okay, so I am representing the refractive index of ore, that is omega, refractive index of ore, that is omega. In many of the books they will mention that is n omega. Okay, they are representing omega as velocity, n omega as refractive index. So there not be so you don't need to get confused there. So omega is refractive index here in this diagram. Okay, so it is represented in this axis. This is omega is the refractive index and this is the vibration direction, B is the vibration direction. Okay, in that vibration direction I am representing the refractive index here. This is A direction of A axis. Here it is omega. Omega is the refractive index and I am representing that in this direction or in a direction within the basal section. So what will be this section? If I am connecting these two, and this is having omega, both of them are having equal radius. What is radius? Radius is the refractive index. Okay, so this will give you a circular section. Then talking about extraordinary, what will happen in extraordinary? Here it is epsilon. Epsilon is refractive index. Refractive index of E ray will be epsilon, or you can take n epsilon. Okay. Talking about positive mineral, what happens? Omega is greater than V omega. Velocity of O rays should be greater than velocity of E rays. That means n omega, or refractive index should be lesser than n epsilon. For negative minerals, the condition is velocity of O ray is lesser than velocity of E ray. That means refractive index of O ray should be greater than refractive index of E ray. So in uniaxial mineral, the n omega and n epsilon differs. N omega and n epsilon, that will differ. So you can see in basal section I am representing omega or n omega, refractive index of O ray, and in principal section, that means along the optic axis or containing the optic axis. E ray vibrate containing the optic axis, O ray vibrate perpendicular to the optic axis. Okay. So if I am taking E ray or refractive index of E ray in this axis, this is unequal, right? This is unequal. This is omega, this is epsilon. Either epsilon will be greater, either n epsilon will be greater when that is positive, or that will be smaller for negative. In any case, positive or negative, but both of them are unequal. Epsilon is unequal than omega. So if I will connect this figure, if I will connect this epsilon and omega, what will be the resultant structure or resultant figure? That will be a ellipse. That will be a ellipse. So if I will join n epsilon and n omega, they will give you a elliptical section. When I will join n omega and n omega, that will be a circular section. And that circular section we can obtain perpendicular to optic axis. Here, in this case, that is AB plane. In uniaxial mineral, that is AB plane, or you can say that is the basal section, only in case of uniaxial, not in case of biaxial. Okay. So you can get a circular section here if n epsilon is smaller than n omega. You can see in this figure here n epsilon is smaller than n omega. N omega is greater, O ray refractive index is greater, epsilon refractive index is smaller. So here we will get an oblate spheroid. Here we will get an oblate spheroid, because in this section the radius will be greater, and in vertical section that will be compressed. So that is oblate. And for oblate, as I have told, n epsilon is smaller than n omega. That means velocity of E ray is faster than velocity of O ray. So it is negative mineral. It is negative mineral. Talking about this ellipsoid, here you can see this is refractive index of O ray and this is refractive index of E ray, right? And here you can see n epsilon is greater than n omega. That means refractive index of extraordinary is greater than refractive index of ordinary. So velocity of E ray is smaller than velocity of O ray. So that will show you a prolate ellipsoid, because that is vertically expanding and horizontally compressing. So that is prolate, which is defining a positive mineral, which is defining a uniaxial positive mineral. Okay. So that is all about your uniaxial minerals. As I have told you, the optic axis that coincides with the C axis, because we are getting the circular section which is perpendicular to C axis here. Here this is the circular section and here it is the circular section. If I will join only these two, A, B, then I will get circular. If I will join A and B, C and B, then I will get ellipse. If I will join C and A, then that will be a ellipse. So in 3-dimensional, that will be either prolate or oblate. Okay. So these are the procedures I have already discussed regarding this. Isotropic I have also told you, you will get spherical indicatrix and each section is circular. Okay. Yes, these are different sections. As I have told you, what is basal section, what is principal section. There are 3 sections, right? Principal section, then circular section and random sections. What about principal section? That containing C axis or optic axis is parallel to the stage. If this is the stage, the mineral is like that. The mineral C axis lies parallel to the stage, right? Mineral C axis is lying parallel to the stage, so that is principal section. Okay, here light rays are perpendicular to the C axis. Light rays are perpendicular to the C axis, so that is principal section. It will be useful in interference figure, so that I have discussed here. Talking about circular section, what happens? The mineral is like this on the stage, the optic axis is like this. Because if I'll cut a section which is perpendicular to the axis is a line, so that will show a point. Okay, so if I'll make to pass the light ray here, those are parallel to the optic axis. So if you are viewing a circular section, or if you are viewing a basal section of tetragonal mineral or hexagonal mineral, okay, they can ask you with examples. Let's say a hexagonal quartz, right? They will ask you what will be the indicatrix for basal section of a quartz. What is hexagonal? So if someone will ask you what will be the shape of indicatrix for a basal section of quartz, the answer will be prolet. I am talking about basal section, means that is a plane, that is two-dimensional. Okay, that should be circular. If I am talking about indicatrix, that is circular when optic axis lies perpendicular to the stage or optic axis is parallel to the light rays. You can see here, this is the light rays, these are the light rays, and optic axis is perpendicular to the stage. So light rays, these are migrating parallel to the optic axis. Then there will be no double refraction. You are getting circular indicatrix, there will be no double refraction. So which interference color you are going to see? There will be extinction. So they can ask you that, or someone can ask you what is the interference color you are watching in basal section of quartz or basal section of zircon. Zircon is tetragonal. So in basal section of zircon, what kind of interference color you are going to view? Then you are thinking like that, how can I remember that zircon is a mineral and there are so many minerals? How can I remember in which section of a mineral I am going to get which kind of interference color? But the logic is that that is asked basal section of zircon. So in basal section, zircon is tetragonal, that is uniaxial. Basal section is extinct, that is isotropic. So you will get basal section is isotropic. That means basal section is showing circular indicatrix. So you will get no interference color. You will get extinct. Okay. So the questions can be like this. Then talking about random section, that means the optic axis is oriented like this. If this is the mineral, the optic axis is oriented, that is not perpendicular, not parallel, any of the other sections. Okay, so you can see the different sections. This is principal section. You can see optic axis is lying parallel to the stage. Optic axis is lying, you can see this is the optic axis, that is lying parallel to the stage. So that will be your principal section. This is circular section when optic axis lies perpendicular to the stage. Okay, so you will get no interference color, you will get circular indicatrix. This is random section. You can see the optic axis that is inclined, So in random section you are going to obtain an elliptical section. Indicatrix is ellipse and you are getting different wavelengths, different refraction or refractive index for O ray and E ray. Then what is E dash? Here it is mentioned E dash. I have forgotten to say that E dash. I have taken O ray, omega and epsilon, right? Then what is epsilon dash? That is another difference between ordinary and extraordinary. That is another difference between ordinary and extraordinary. For ordinary ray, that is having same refractive index for different sections of mineral. This is a mineral, it is having different section. One is this section, one is this section, one is this section. Okay, principal section I am talking about. One is AB, we are talking about. This is a section AB. This is, you can see this section is BC, this section is AC. These are three principal sections. There are other different random sections are also there. Okay, in each section O ray is having same refractive index. O ray is having constant refractive index for a mineral in each section. Constant refractive index in a mineral. Okay, the refractive index that remains constant for a mineral. Extraordinary ray, that refractive index varies. That refractive index varies in different section. Varies in different section of the mineral. Talking about different section of a mineral, that is principal or basal, that will vary. The E ray refractive index will vary. The epsilon will vary. The magnitude will vary. Right. So what happens? That's why you are getting elliptical section. One more thing is that if this is the basal section, if this is the basal section, okay, and this is the principal section. This is the basal section. Let's consider in two-dimensional, that will be easier. Okay, this is the basal section, this is the principal section. Let's say this is C axis, this is A axis. So in A axis what happens? Omega is equal to epsilon. Omega is equal to epsilon. Why? Why? Because optic axis is here, which is parallel to C axis. Optic axis is here, which is parallel to C axis. That means there will be no double refraction. There will be no double refraction. What do you mean by no double refraction? They will split up into two rays. That is anisotropic mineral. They will split up into two rays, but both of them are lying in same position. That means there will be no retardation. There will be no retardation. If O ray is here, E ray is here, they will have same retardation and they will travel in same path. They will travel in same path. What happens? Here this is the, you can get ordinary here, you can get extraordinary here. That means at the same position in same direction you can find both of the rays. So that is known as no double refraction. Both of the rays you are finding in same position. Okay. When that will obtain, when you can obtain that, when that is perpendicular to C axis. The section is, this is the section which is perpendicular to the C axis. So in this section you are getting omega is equal to epsilon. In principal section what happens? Whenever you are taking this section, right, as I have told you, if this is C, you are taking either AC or BC, right? If you are taking that section, what happens? The rays will migrate in same path. The rays will migrate in same path, but you are getting in different distances. In different distances. This path difference is known as retardation. This path difference is known as retardation, and that depends if mineral is positive. If mineral is positive, O ray will be faster, epsilon will be here. If the mineral is negative, then epsilon will be faster, O ray will be here. Okay, I am talking about velocity. Got that? This is in principal section. That means when light ray is perpendicular to C axis, you are taking AC or BC section, what happens? The light rays, they are migrating in same path but at different velocities. Okay, and that is maximum. This difference is maximum in case of principal section, and this difference is zero in case of basal section. Got that? here omega is equal to epsilon, here omega minus epsilon mod is maximum. Mod, why I have taken mod? Either omega will be faster or epsilon will be faster depending upon mineral is positive or negative. So this difference is maximum in case of principal section. In any other section the epsilon will vary. Got that? The maximum refractive index of extraordinary ray is termed as epsilon. Okay? Epsilon is maximum refractive index of extraordinary ray. Okay? Ordinary ray is equal to epsilon in minimum or it can be minimum or maximum, right? It can be minimum or maximum depending upon mineral is positive or negative, right? So omega is equal to epsilon in basal section. In between that the value will be epsilon dash. Epsilon dash is either greater than omega and less than epsilon, or it can be omega greater than epsilon dash greater than epsilon. So if I am talking about refractive index, omega is less than epsilon dash and epsilon. I am talking about refractive index of O ray and E ray. So E ray is having greater refractive index, that means it is slower, so mineral is positive. Here the refractive index of O ray is higher, that means O ray is slower, so mineral is negative. So this is the condition omega less than epsilon dash less than epsilon. If I am talking about refractive index, that is positive, then omega greater than epsilon dash greater than epsilon, that will be negative. So epsilon dash will be the refractive index of extraordinary ray in random section. Epsilon will be the refractive index of extraordinary ray in principal section. Omega will be refractive index of O ray or E ray in basal section. Got that?